Hey everyone, today we're going to do some multiple choice practice. This is a great way to practice for the test or the quiz or anything that's happening in Chapter 3 right now. These rules with the derivatives that we've been practicing, you really, to nail these down, you have to do some AP problems. So students will be able to solve derivative multiple choice problems today. So some things that we've been talking about: chain, product, quotient rule, derivative, limit definition of derivative is going to come back a little bit, and then trig derivatives. So limit definition of derivative, there are two of them, remember. Limit is h approaches 0, f of x plus h minus f of x divided by h, and also the limit as x approaches a, or a approaches x, either way, of f of x minus f of a over x minus a. Now you'll see why that's going to come into play, I think, pretty quickly here. But this is, I'm doing this in two videos. This is what I would call kind of the harder problems, ones that people tend to struggle more with. And so we'll take a look at these and see how we do. So we're looking for the equation of the tangent line to this graph at the point 1, -1. Hey, they gave us the point. Yay! You can plug in 1. It should give you -1. I'm not going to waste my time doing that. So all I need is the slope. So I need f prime of x. Well, f prime of x is going to require product rule. Right? So the derivative of the first thing is 1. Leave the second thing alone, 1 minus 2x cubed. Plus, now you leave the first thing alone. The derivative of the second one requires product or chain rule. The 3 will come to the front. 1 minus 2x times to the second power, so reducing 1, and then multiply by the derivative of the inside function, which is -2. So I had to chain that. Now we're evaluating this at x equals 1, right? All I care about is that x coordinate for our derivative. So this 1 I don't really care about. 1 minus 2 is -1 cubed. That's a -1. Plus 1 times 3 is 3. Let's write that out. Times 1 minus 2 is -1 squared is 1 times -2. So altogether it looks like we have -1 minus 6 more is -7. So now, right away, which one do we know it is? There's only one here that has a slope of -7. It's this guy. Let's double check though. Y plus 1 equals -7 times x minus 1. Well, so we're written in slope-intercept form here, so we've got to distribute. Y plus 1 is -7x plus 7. Subtract 1 from both sides. Y is -7 plus 6. There you go. That's all there is to it. Let's try the next one. In the xy plane, the line x plus y equals k, where k is a constant, is tangent to the graph of y equals x squared plus 3x plus 1. What is the value of k? Now, sometimes people see this and they think, gosh, I have no idea how to do this. But if you think a little bit and you try it, we'll see if we can knock something out. So x squared plus 3x plus 1. This is a graph that it would be a parabola. I have no idea what the parabola would look like, so let's say it looks something like this. This guy, x plus y equals k, this is some kind of a line. Well, we can get a little bit of a heads up on this. Y equals -x plus k. What does that tell us? That tells us that the slope of this line is -1. So it's going to be somewhere over here probably. Okay? So the slope of that line is -1. So that's important, right? The slope of this tangent line is -1. The slope, remember, of the function at any point is equal to the derivative, right? So let's find y prime. So y prime is 2x plus 3. So I know that whatever this x coordinate is, this has got to be equal to -1 at that point. So I'm trying to find what this x coordinate is right now. Okay? And often when I'm going through this, I don't really have a plan for where I'm going. I just know certain things have to be true. Right now, I know the derivative has to be equal to -1 to make this line tangent to this graph. So I'm going to set this equal to -1. Now we'll solve for x. So 2x is -4. That means x is -2. Interesting. So I know the x coordinate is -2. That goes here. It also goes here. So I can find what the y coordinate is by plugging in -2. So y of -2, so I'm kind of using function notation with y here. Y of -2 would be -2 squared plus 3 times -2 plus 1. So that would be 4 minus 6 plus 1, -2 plus 1, which is -1. So I have an x, that's a y. Hey, x plus y equals k. So -2 minus 1 equals k, which is -3. There you go. All there is to it. So, I feel like I didn't explain myself well when I was going through that, but basically what I did, I took the derivative, set it equal to the slope of the line, because there's only one place your slope's going to be -1 on a parabola, and then I solved for what the x coordinate is there. I was able to plug that into this function to find y, and then x plus y must always be k, which is your constant. So we added them together, and that gave us k. Cool. All right, yes, two values we have to find here, c and d. So they tell us it's differentiable. Two things we need for differentiability. One is that it has to be continuous. The second is that the derivatives have to be the same on both sides. Now, people sometimes ask me, which one do you do first? Well, I always aim for the derivative first, which I know is counterintuitive for what we just wrote, but it makes sense to me because when you take derivatives, things disappear, right? So f prime of x, let's figure that out, is going to be just c for that line. That's just a slope, right? It has a constant derivative for x less than or equal to 2. And the bottom one will be 2x minus c when x is greater than 2. Now we only have to deal with c. We don't have to worry about d for now. We'll come back and do that later. So when I plug 2 into these, the derivative from both sides has to be the same. Well, the derivative of the top one is just c all the time. The bottom one, when I plug in 2, gives me 4 minus c. Those have to be the same, because that's what's happening at x equals 2. So 4 minus c has got to be equal to c. Add c to both sides. 4 equals 2c, so c is 2. Now that we have c, we can find d by plugging 2 into the original function, because it's got to be continuous. When I plug 2 into both of them, they have to give me the same y value. So we know c is 2. So right now we have f of x is 2x plus d, x less than or equal to 2. And it's x squared minus 2x when x is greater than 2. So now we'll plug 2 into both of them and set them equal. That's it. So 4 plus d has got to be equal to 4 minus 4. That is at 0. So d is negative 4. So we've got c is 2, d is negative 4. They ask for the sum. Negative 4 plus 2, negative 2. That's it. Tricky problem. Key is doing the derivative first, I think, and then going back to continuity. Yes, f and g are twice differentiable. H of x is f of g of x, so composition. Looks like we'll be using some chain rule. They're looking for the second derivative of h. Let's find h prime first. H prime, just straight up chain rule. F prime at g of x times g prime of x. Now we have to do the second derivative. We're going to have to use product rule because we have a product of two functions. So the derivative of the first part is going to require chain rule again. So I do f double prime at g of x, leave it alone. Multiply by g prime of x again. And we leave the g prime of x alone. So that was the derivative of this part. This was the derivative of the first part of the function. We multiply by g prime of x. Excuse me. Then we add to that, leave the first part alone, f prime of g of x, and multiply by the derivative of the second one, which is just the second derivative. So we're just stacking derivatives with that g prime, double prime of x. Now we're probably going to have to do some algebra to figure this out. Let's see. So that is f double prime of x, of g of x. That only happens once. G prime times g prime, that is g prime of x squared. And then we add to that, let's see, f prime times g double prime. So f prime of g of x times g double prime of x. I don't think we can factor anything else out. It looks like there's nothing else shared in common. So let's see if that's somewhere. So we're looking for f double prime times g prime squared. We've got that here. Plus f prime of g of x, g double prime of x. That's it. That's A. So, wow, chain rule and then product rule along with chain rule a second time. Tricky problem. You can see why I chose these for the hard ones. Okay, I haven't done this problem in a while, so let's see how it goes. Derivative of f of x is g of x. Okay, so f prime of x is g of x. Interesting. So that would be like if f of x was x squared, then g of x would be 2x. So they're just telling us that g of x is the function that's the derivative of f. Okay. Derivative of g of x is f of x squared. Interesting. So g prime of x is f of x squared. They want to know the second derivative of f of x cubed. Okay. Interesting. Well, let's find the derivative first of f of x cubed. That sounds like a chain rule problem. X cubed is our baby. So it would be f prime of x cubed times the derivative of the inside, which is 3x squared. Well, we have something about f prime, though. F prime is g. Interesting. So this is g of x cubed times 3x squared. Okay. Now let's do the second derivative. So the second derivative, d squared dx squared, of f of x cubed is going to be the derivative of what we just found. the derivative of g of x cubed times 3x squared. Now, I'm not sure if changing that to g is going to be helpful, because whatever way they answer might be different, but let's start with that and see what happens. So the derivative of this guy, we're going to have to use product rule. Derivative of g, so we have g prime of x cubed times the derivative of the inside function, which is 3x squared. So that was the derivative of the first part. Leave the second part alone, 3x squared. And then we add to that, leave the first part alone, g of x cubed, multiplied by the derivative of the second, which is 6x. Looks like it's going to be d. We'll have to flesh it out, but I'm pretty sure it's going to be d, because that's the one that has that 6x hanging on. So let's see. So g prime of x cubed, they tell us g prime is f of x squared. So g prime of x cubed is going to be f of x cubed squared, right? Because g prime of x is f of x squared, so g prime of x cubed is going to be f of x cubed squared. Multiplied by, let's see, 9x to the fourth. Yeah, this is looking real good. Plus 6x g of x cubed. Yep, 9x to the fourth, f of x to the sixth, plus 6x g of x cubed. Weird problem. It's weird that they have these relationships. I would be interested in hearing what these functions actually are. The derivative of g of x is f of x squared. The derivative of f of x is g of x. Weird. All right. That the last one? That was the last one. So those were kind of the ones that people tend to struggle with. Feel free to scroll through these, watch them again. Some tricky problems in there, but a lot of fun. Gosh, AP writes good problems. Love you guys. That's why I'm here. Have an excellent day.